Have you ever wondered why, no matter what you do, a very specific, sharp body odor just keeps coming back? Well, today, we're going to pull back the curtain on the precise biochemistry behind that experience. We'll find out exactly why the usual solutions so often miss the mark. So let's start with the big question, the one that probably brought you here. You shower, you put on deodorant, and yet, just a few hours later, that really distinct kind of onion-like smell is back. It's an incredibly common and frustrating experience. The real question is, why? What is actually going on?
Okay, the very first thing you need to know is this. You are not doing anything wrong. Seriously, this has nothing to do with your hygiene. The simple truth is your deodorant was never built to stop this particular smell. Why? Because as you're about to see, it's caused by a completely different and, frankly, a surprisingly sophisticated biological process. To understand the odor, we have to trace it all the way back to its origin. And it all begins inside your body, with the creation of something that has no smell at all, a molecule we can think of as a sealed, odorless parcel.
Deep inside your armpits, you have these special sweat glands called apocrine glands. You can imagine them as tiny, highly specialized factories. Their only job is to build a very specific molecule, carefully wrap it up in a protective chemical shell, and then deliver that finished package right up to the surface of your skin.
And this whole process is incredibly precise. Let's break it down. First, inside the gland, the core molecule hitches a ride on a carrier. Then, a special transporter protein, and we'll come back to this protein, it's important, pushes that entire package out of the cell. Finally, an enzyme on the outside neatly trims the package into its final, stable form. And there you have it, a perfectly sealed, completely odorless parcel just sitting on your skin.
Now, what's really fascinating here is that this entire delivery system, this whole microscopic production line, is controlled by just one single gene. It's called ABCC11. It basically acts as the master on-off switch, determining whether these parcels get made and delivered in the first place.
This chart shows just how significant that genetic switch is across the world. You can see that in most East Asian populations, less than 10% of people have the active version of this gene. For them, the factories are mostly shut down. But if you look at populations of European and African descent, it's the complete opposite. Over 95% have the active gene, meaning their factories are running pretty much all the time, constantly delivering these parcels.
And here's a really simple and kind of strange way to know your own genetic status. That same ABCC11 gene also determines what kind of earwax you have. If you have the wet, sticky type of earwax, it means you have the active gene. Your parcel factory is open for business. On the other hand, if you have dry, flaky earwax, your gene is inactive and the factory is closed.
All right, so we've established how your body creates and delivers this odorless parcel. But the parcel itself is harmless. The real action happens when it collides with the world of bacteria living on your skin, what scientists call your microbiome.
The key player in this story is a very specific skin bacterium called Staphylococcus hominis. Now, this particular microbe has a unique tool in its arsenal, a special enzyme called lyase. You can think of this enzyme as being like a key, one that's designed to fit a very specific lock.
And of course, the lock for that key is the odorless parcel we've been talking about. The lyase enzyme seeks out that parcel on your skin, and with almost surgical precision, it snaps a single chemical bond. The moment that happens, the parcel is cracked open, and it instantly releases a brand new molecule, a highly volatile substance known as a thioalcohol.
So why that distinct onion smell? It's just simple chemistry. That thioalcohol molecule that gets released contains sulfur, and that is the exact same element that gives onions their sharp, recognizable smell. So when the bacteria crack open the parcel, the smell they create is, chemically speaking, identical. This really means that your unique body odor isn't just about you. It's determined by which bacteria happen to be dominant in your armpit. If it's mainly Corynebacterium species, they produce things called volatile fatty acids, and that leads to a more common sour or cheesy body odor. But if Staphylococcus hominis is the dominant species, it makes those thioalcohols, and that's when you get that distinct, sharp onion smell. Same person, different bacteria, completely different odor.
So now we've mapped out the entire pathway, from the gene to the gland to the bacteria to the final odor. But this brings us right back to our original problem. Why don't standard deodorants work against this? The answer lies in three incredibly powerful biological defenses that this system has.
These three defenses are what make the problem so persistent. First, you have biofilm fortresses. Second, a continuous supply of the source material. And third, the extraordinary efficiency of the enzyme itself. To really stop the smell, you have to overcome all three of these at the same time.
Let's start with the first defense, the biofilm. See, these bacteria don't just sit on the top layer of your skin, they actually colonize deep down inside your hair follicles. And in there, they build this sticky, protective shield around themselves called a biofilm. Deodorants are really just surface-level products. They simply cannot get through this biological fortress to reach the bacteria hiding inside.
The second defense is that relentless, continuous supply. Your apocrine glands aren't just working when you sweat from exercise. They are active 24/7, constantly delivering a fresh, non-stop supply of odorless parcels to the surface. You can wipe the skin clean, but that only gives you a few moments of peace before that supply line is right back up and running.
And finally, there's the third defense, the sheer efficiency of the enzyme. That lyase enzyme is astonishingly good at its job. It works so fast and so powerfully that you don't need a huge colony of bacteria. Even a tiny little group that survives a deodorant application can produce more than enough of those volatile thioalcohols to create a very, very noticeable odor. So, now that we've laid out the science behind the problem and we understand its three powerful defenses, the path to a real solution becomes perfectly clear. It's obvious that it requires a completely new way of thinking.
Based on all the science we've just gone through, any truly effective solution must achieve three things simultaneously. Number one, it has to get past that protective biofilm to actually reach the bacteria where they live. Number two, it has to find a way to interrupt that lyase enzyme to stop it cracking open the parcels. And number three, it has to be able to neutralize any of those smelly molecules that still manage to form.
No deodorant can do this. Deodorants were designed to reduce surface bacteria. That is it. They were never built to penetrate biofilm, interrupt enzymes, or capture volatile molecules.
If you can find products on the market that addresses all three of these defenses simultaneously, use them. If nothing works, visit superdeodorant.com and look into our volatile control system.
We spent years researching the biochemistry of body odor, and we built the Volatile control system specifically for problems deodorants were never designed to solve.
You know, the science we've gone over today is really the foundation of everything we do here at Super Deodorant Laboratories. And the onion pathway is just one of many distinct odor pathways that we've researched. If you'd like to explore the peer-reviewed science for yourself or learn more about our ongoing work, please visit us online. Thank you for joining us for this explainer.